And if you look through your chart in your book, you will see that there are different organizations to these cleavage planes, different geometries, and that can be very distinctive for being able to tell which mineral is which. Now here's a complication to the whole thing. Instead of just having cleavage to look at for planes and minerals, you can also have other planes that have nothing to do with cleavage, and these are what are called crystal form. So you can have these beautiful crystals here that also seem to have planes on the outside, but that's all. They only have the planes on the outside of the mineral. Inside the mineral, they will break apart in a completely different manner. So for example, this mineral of fluorite has a very nice, even mineral shape to it, but inside it will not break the same way. Even better is this piece of quartz, and quartz makes a beautiful crystal with nice flat edges on the outside, but if you break it apart, notice the inside looks like this broken piece with all of these fractured surfaces. So quartz has no cleavage, it has fracture, even though it makes such nice crystals on the outside. Finally, there are a group of distinctive properties to specific minerals. So you may have gone through all of these other properties and figured out everything and got it down to the last point, and there may be one last property that you might have to use to be able to determine it. Now sometimes it's going to be that cleavage, angles, or how many cleavages will tell you what they are, or even the color of the streak and things like that may be distinctive to tell you exactly what the mineral is. But in other cases it may not be. And some of those things we can talk about here. First of all, there may be things like what is called specific gravity. Is a mineral heavy to the touch or is it light? So you might be able to pick up two minerals and say, wow, this one's a lot denser than this one is. So just specific gravity may be able to help you to determine what the mineral is. On the other hand, there may be some other relatively easy things to do. For example, this mineral, if you scratch it up using another mineral or a plate or anything else, and sniff it, it smells. This is sulfur, so you get a sulfury smell on it to be able to tell you what the mineral is. Otherwise, we have a mineral like this. This is the mineral halite. You know what halite is? It's table salt. Sure enough, it tastes like table salt. So taste might be another way to determine what mineral is what. Other things on these minerals, this is the mineral calcite. You can get a bottle of dilute hydrochloric acid from your lab assistant, and what you will do is put a drop on top and it will fizz if it is calcite. Calcite is the only mineral that will fizz when you put the drop directly on. Other minerals might be magnetite, and magnetite, you have a magnet in your kit, a little magnet, we put it on and the magnet holds, and so therefore that is magnetite. It's the only mineral that will do that. Other things might be on this mineral, which is plagioclase. Plagioclase tends to have what are called striations, which looks like someone took a knife and cut it over the surface of the mineral. So that is another distinctive characteristic. Potassium feldspar commonly has little veins running through it. So the color is not even, but has veins of color running through it. And so therefore, these are several of the different ways you can look at these. If you think for all the world you got calcite, but it's not fizzing when you put that acid on it, there's one other mineral it might be. It could be the mineral dolomite. Dolomite will, however, fizz only in the powdered form. So what you need to do is to take your sample, rub it on the streak plate until you get a little streak on there, and that will be powder. Drop the acid on that, and that will fizz. That's the only way it will work. If it doesn't fizz here first, try that second. Oh, will this guy ever stop talking? God, I'm tired. I want to get out of this. When is this class over? Oh, sorry. Now I'm being a student, see? And so therefore now what I'm going to do is I'm going to go through the whole way of how we figure out what mineral is what with you. So we're going to take an unknown, and we're going to go through the whole step-by-step process, fill in a form, and then I'm going to show you how it's all done. Okay, first thing is we have our kit, and we have our book, we have our form to fill out, and we have our unknown mineral. And this is our unknown mineral. So what we're going to do is go through step by step. So first thing, since I'm a student, I'll say, how does he expect us to be able to figure this out? All right, so how do I expect him to be able to figure it out? First thing, let's start the first test. Is this mineral a metallic lustered mineral, or is it a non-metallic luster? Well, certainly this doesn't look like a piece of metal. So let's start off with step one, it's not metallic. Second test I'm going to do, I already said that it's a non-metallic luster. I'm going to look at the hardness of the mineral. So let's see, what's the hardest thing in my kit? My kit has a streak plate in it, and the streak plates have a hardness of 6.5. So let's try the streak plate. And it makes a mark on the streak plate, but as soon as I rub it off, it disappears. So therefore, it is not as hard as the streak plate. Let's try the glass plate. Glass plate has a hardness of 5.5. And it indeed did scratch the glass plate, so it's harder than 5.5. I don't even have to bother with the rest of them because I already know that the hardness is someplace about 6. Okay, so we got luster, we got hardness. What's the next thing? It says on the chart, look for the cleavage. Okay, so what we're going to do then is we're going to rotate this around and try to glint the light off of some of these surfaces and see if we see any cleavage planes. I see one clear cleavage plane in this direction, and I rotate it around, and there's another one in that direction. So now I see two cleavages at about 90 degrees to each other, and I don't see any other cleavages throughout the mineral. Well, there's one that's parallel to this one, so I can see them on opposite sides of that mineral, but clearly I have two directions of cleavage at approximately 90 degrees to each other. Now I'm looking at my chart, I'm figuring out what this is, and I've gotten through that the luster is non-metallic, a pretty hard mineral, hardness of 6, I got cleavage in two directions. I can go through, I have two things that it's down to. It's either potassium feldspar or plagioclase feldspar. Those are my two possibilities. One of them has striations on the surface, and so I can look for striations, and the other one, as I know from before, might have little lines in it, but it will not have those knife marks on the surface. So what I'm going to do then is I'm going to take this sample and I'm going to look closely to see if I can find the striations. And clearly we don't have the knife marks on the surface. However, we do have these little vein-like lines cutting through it, and so therefore this one I will conclude is potassium feldspar. Okay, now that I've completed all of my tests, it's time for me to fill out this chart, which I will hand in to my lab TA for grading. And so therefore I want to be able to fill out all the columns in here. The first column, it says, what's the luster or color? So here I see that it's a non-metallic. The color is white. Second column asks me what the streak is. I would take my sample, run it on the streak plate, and find out that the streak is white. We have already determined that the hardness of this mineral was a 6. This next thing is cleavage and fracture. We determined that it has two directions of cleavage, and they were at about 90 degrees to each other. Crystal form, well, we didn't see any crystal form. This is not a crystal substance, so therefore we write none. Specific gravity, it's relatively light. And we've determined using this book that it's potassium feldspar. Now this last column, which is for most distinguishing properties, is the most important of all to you, because you are going to have, at a future time, at your midterm exam, you're going to have to be given a bunch of unknown samples, and you're going to have to be able to determine what they are without the use of your book. So here what you need to put in this is to be able to give it a distinguishing feature so that in the future you look at it and you say, oh yes, that's potassium feldspar. And therefore it may be one of the things that are already on this chart. It may be the cleavage that gave it away to you, or the color, or whatever it was. It could be on the chart, or perhaps it wasn't. In this case, one of the things that didn't go on the chart was that it had those little white veins on the cleavage surface. And therefore maybe you want to write the white veins in here. Or maybe you want to write that it's the cleavage that gave it away. Whatever it is to you, it's so that you can identify this mineral in the future and that you can study for the exam and get 100%, as I expect you all to do.